Hi everyone. So in this session I am going to be discuss about the traveling salesperson problem using dynamic programming. First I want to explain discuss what is the problem statement of traveling salesperson problem. Traveling salesperson problem is nothing but find a route traveled by the salesperson starting from any one vertex and visiting each vertex exactly once and returning back to the last vertex to the starting vertex. Once again I am repeating, this is a route travel by the salesman starting from any one vertex and visiting or touching each and every vertex exactly once, and from last vertex to the starting vertex it must be written back. So while complete this route, the salesman is going to be spend minimum amount. So when our solution demands the minimum value, so this problem we technically called optimization problem. And when it is a minimum solution, then it must be called as a minimization problem. So now, for example, we have a graph with 4 vertices. Let us assume vertex 1, vertex 2, vertex 3, vertex 4. Let us assume. So this is a graph, and it having some cost. Maybe it is a directed graph or undirected graph. If it is undirected, 1 to 2 have one edge cost and 2 to 1 is maybe different. So like, so in dynamic programming, how we are going to be solve this one? So first I will construct the state space tree for this traveling salesperson problem. Like, I visit the vertex 1. That means I fix my source vertex, that is like 1. I visited. I started my journey from vertex 1. When I am at the vertex 1, second possibility, nothing but my second visiting vertex, it may be the 2, or it may be the 3, or it may be the 4. If I visit vertex 1 and 2, it must be either 3 or 4. If it is I visited 1 and 3, it must be either 2 and 4. If I visited 1 and 4, then it may be either 2 or 3. Let us assume I have visited in this path 1, 2, 3, then there is no choice for us, we must visit the 4. If it is 4, nothing but in this path 1, 2, 4, there is no choice for us, we must be visit the third vertex. And in the same way, if I go over this path 1, 3, 2, then it must be the 4. If it is 1, 3, 4, then it must be the 2. If it is 1, 4, 2, then it must be the 3. And if it is a 1, 4, 3, and it must be the 2. And from this last vertex to, according to our problem statement, we must be reach our source. What is our source? 1. So like 1. So for this we are going to be find the solution which cost is a minimum, that we are going to be say the traveling salesperson problem, nothing but the traveling salesman is going to be completed his journey with that minimum cost. So to achieve this one, if you are clearly observe for this problem statement, we find the solution from bottom up approach. Like, first we find the solution for what is the cost of 421, then 321, then 421 and so on. Then what is this cost that is initially, and when I am at this level I am going to be find the traveling cost from 324 and 421 or 423, 321 and so on. When I reach here I am going to be find the minimum of either 341 or 431 at the node 2. For node 3 the minimum of either 241 or 421. For at the node 4 the minimum of 231 or 321. So once I find the minimum values traveling cost at the node 2, 3, 4, then only I go for the find the minimum cost at node 1. So this is the minimum of the node cost 2, node cost 3, node cost 4 plus this edge cost like. So for this one we are going to be write a recursive formula as well as the base case. So this is the base case, and from this all are recursives. So what is the base case? Base case is nothing but my set, nothing but when I begin with 4, what is that meaning? If you are clearly observe this path, I visited 1, 2, 3 and 4. Totally I have the only 4 vertices from the given example. So that means there is no vertex to be visited. So in other words, I am going to be find the cost of at the node 4. What is that cost? Indirectly the edge cost of this 4 to 1, because 1 is a source, and the set here there is no other vertex to be visited future, because you visited all these 4 vertices, then only you are at this moment. Maybe we find the solution in backtrack, nothing but in reverse. So that means 4 and all other vertices are visited. In other words, there is no vertex to be visited. Pi is nothing but the empty, nothing but all we visited the vertices. So what is the g of 4 pi? C41. What is the g of 31? G of 21 like. So that means what is the base case? Except to source, from all other vertices to the source vertex, what is the cost we needed? That is nothing but edge cost, that will be given by our cost matrix, or nothing but adjacent cost matrix. For example, if the cost is 10, then the C of 41 is the 10 I am going to be mentioned, nothing but G of 4 pi is nothing but the 10 and so on. Now when I try to write here my formula, like if I am going to be write my formula here, G of 3 to this thing. So when I am at the node 3, that means I have visited to 1, 2 and 3, nothing but out of 4 vertices I have visited 3 vertices, 1 vertex is only pending. What is that? 4. That means my set consists of only 1, my set length is 1, that what is that? 4. How I find the cost of G 3 to this area? How I will find? The simply the edge cost of this 3 to this set first vertex, this set may be having only 1. What is that vertex? 4. So that's why this is nothing but the cost of 3 to 4 plus the G of that 4. Which vertex we have chosen? This 4. Nothing but from 3 to 4 we reach. So 4 to, from that set we are removing this 4, that is nothing but empty set. So if you have more than 1, then we are going to be apply the minimum of this one. So that is our recursive formula. For example, if I write the recursive formula for g of 2 with nothing but, when I am writing the g of 2, I visited 1 and 2. Maybe in future I would with a 3, maybe nothing but first visit 3 or maybe first visit 4. I want to visit 3 and 4, but the visiting order, it may be the 3 then 4 or 4 then 3. So that means my set having either 3 or 4. So that is nothing but the minimum of the cost. If it is 3, what is the edge cost of 2 to 3? I must be considered, plus the total cost of that 3 to, what is the set initially? 3 4, nothing but 3 4, you visited 3, nothing but in future which vertex you are going to be visit? 4 only, nothing but, in other words 3 to 4 we are going to remove the visiting vertex. Which vertex we visited? 3, or either that is minimum, or the cost of 2 to, earlier I visited the 3, I do not know which path gives us a minimum cost, whether it may be 2 to 3 or 2 to 4, 4 onwards, I am going to be check it. So, 2 to 4 cost plus the overall cost at that node, that will be given by g of 4 comma from that set 3 4, which vertex we visited now? 4, nothing but which vertex you want to visit in future? 3. So, that means in other words better to write 3 4 from that set, you must be remove the 4. So, which is minimum, that we are going to be considering. So, this is our recursive equation. So, when our set having it some elements, so that is why this is true for set not empty. And what is the this case? This is the base case. What is the base case? When our set is empty. So, this is our base case. Now, we try to solve with an example. So, I am going to be consider this example. So, for this one, so it is a undirected graph, directed graph, 1 to 2 and 2 to 1 is different. So, that is why I am not going to represent all the values here. For that, I maintain the adjacent cost matrix also. So, this is the adjacent cost matrix. So, let we fix our source vertex is 1. Initially, I am going to be find with my set length is 0. My set length is 0 is nothing but I reached all the vertices. So, what is the possibility of the last vertex except source? So, that may be the 2, that may be the 3, that may be the 4 is. So, that is why g of 2 with the pi. What is that meaning? What is the base case? 2 to source vertex. What is our source vertex? 1. So, the cost of 2 1. What is the cost of 2 1? So, these are all the elements 1 2 3 4 4 rows and 4 columns. Which thing we need? 2 1. What is the cost of 2 1? 5. So, next I will find 3 pi. Any vertex is maybe the last, whether it is second or third or fourth. So, g of 3 pi. So, that is nothing but cost of 3 1. What is the cost of 3 1? 6. And g of 4 pi. What is the value cost of 4 1? What is the cost of 4 1? 8. So, that means from the traveling salesperson, we evaluated the values of, as of now, we find the values of these 4 to this, nothing but either 4 to 1 or 3 to 1 or 2 to 1. This is repetition 2 to 1, 2 to 1, 3 to 1, 3 to 1, 4 to 1, 4 to 1. So, that is why just we find So, we found those values, that is nothing but with set length 0. So, when I know with a set length 0, then only I am going to be find with a set length 1. So, what is a set length 1? That means, so this is for set length 0. So, now I find set length 1. So, set length 1 in the sense, so last but one node. So, if my last but one node is 2, the last one may be the 3 or the last one may be the 4. So, the last but one is 3, that means the last one must may be the 2 or the last one may be the 4. In the same way, for the last but one is 4, the last may be the 2 or it may be the 3. So, we are going to be find these are all values. So, that is with set length 1. So, now this is not the base case, recursive case. What is that meaning? Minimum of, yes, minimum of the cost of your set having only one element, nothing but 2 to 3 you are going to be visit next 2 to 3 plus the g of 3. When you visit 3, what is the in future you are going to visit from that set? Nothing. So, that means pi. So, what is the cost of 2 3? So, we know that cost of 2 3, I am going to be consider this graph for our calculation easier. So, what is the cost of 2 3? So, 2 3 9 plus I know my g of 3 pi value. So, earlier we calculated what is the g of 3 pi value? 6. So, 9 plus 6 is 15. Now, go with a g of 2 4, nothing but the same minimum of the cost of from this set 2 4 plus g of 4 pi. So, we know the c of 2 4 value. What is the cost of 2 4 value? 10 plus we know the 4 pi value. What is the 4 pi value? 8. What is that value? 18. Now, you will find g of 3 2, g of 3 4, g of 4 2, g of 4 3. So, for our convenient purpose already I evaluated those values. So, set 0 over and set 1 over. So, now I am going to be find with a set length 2. So, when I am going to be find with a set length 2 after finding the set length 1, now I am going to be find with a set length 2. So, my set length now I am going to be considered as 2, nothing but g of, if it is 2, then what is my set length? 3 4. So, what is the equation of this one? I am going to be write for this one equation, the rest you must be write yourself. So, the minimum of cost of 2 to either you go with 3 or 4 like 2 3 plus g of, when you visit the 3, what is the other vertex within that set? 4 onwards, nothing but 4 with you visited 3 and 3 with what is the other vertex in the set? 4. So, already evaluate that value earlier. And one more equation also possible, because within the set 2 vertices are there. As of now, we form equation using one vertex, that is 3. So, if I go with 4, so that is why when it is a variable, simply I am going to be say j belongs to set minimum of cost of I j plus g of j comma from that set minus j. So, this is the recursive equation. You must be fine for all possible C's. So, that is why what is one more vertex possible to choose from our set? 4. So, cost of 2 4 plus g of 4 with the remaining element within the set, that is nothing but 3. So, we know the cost of 2 3. What is the cost of 2 3? 9 plus we know the g of 3 4 value. So, g of 3 4 20. So, this value g of 3 4 nothing but this value 20 comma. We know the cost of 2 4. What is the value of cost of 2 4? 2 4 is a 10 nothing but 10 plus we know the cost of 4 3. So, what is the 4 3? This one 15. So, 10 plus 15. Which is the minimum? This is 29, this is 25. So, the minimum is this one. This one is given by which equation? This one. Remember this one, because without maintaining these are all unable to find the final solution, final traveling salesperson route. So, this is the 25. So, g of 2 comma 3 4, what is the value we are getting? 25. In the same way, g of 3 with 2 4, g of 4 with 2 3 we are going to be calculate. So, now we completed with the set 3. Now, we are going with finally with the set length 3. Why I am saying finally? In the sense, whenever we have n number of vertices, once we fix the source vertex, the remaining vertices are only n minus 1. So, in the same way, in this example, how many vertices we have? 4. Out of 4, 1 is a source, nothing but you must have visit the order out of those 3 only, the remaining 3 only. So, that is our last set length. So, the last one we are getting the 3 equations. The last one I am going to write here. The last one is nothing but g of 1 with the set 2 3 4, which is nothing but the minimum of cost of 1 to first element 2 plus g of 2 with other elements in the set, other elements nothing but 3 4 comma c of 1 3 plus g of which vertex you visited? 3. So, nothing but 3 with what is other side elements? 2 4, good, comma, and one more possibility also there, 1 with 4, cost of 1 4 plus g of 4 with the set 2 3. So, like this equation. Okay. Then we are getting these values and we are getting final value as 35. Nothing but we know the answer, but we want to find the solution. In other words, in which way it is going to be gives the path. So, my dear, check it. The 35 is given by which equation? Observe 20 22 42, 15 plus 25 40, 10 plus 25 35, nothing but the first this one. This is the minimum. Minimum is nothing but this equation. This equation is nothing but from which vertex you visited first? C 1 2. So, first I must be reach 1 2 2, then 2 2 I am going to be think with the help of this equation. What is this? G of 2 3 4. So, once again I am repeating, check it. 35 is given by the first equation. What is that one? 10 plus 25. What is the first equation? This one. From this one, the cost of 1 2, that is nothing but that path 1 2 2, and the rest path is given by this equation. What is that? G of 2 comma 3 4. Go with G of 2 comma 3 4. So, G of 2 comma 3 4 is this one. What is that path? 25. Path cost is 25. The 25 is given by which equation? 9 plus 20, 29, 10 plus 15, 25. Nothing but which equation gives us? Second equation. What is second equation? This one. What is that? The path 2 to 4, nothing but 1 to 2 you already reach. Now, 2 to 4 you go with. 2 to 4 I reach. The next will be given by this equation. What is that? G of 4 3. So, go with a G of 4 3. So, what is the G of 4 3? This one. What is the value? 15. 15 is given by which equation? Only one equation, that is nothing but C of 4 3. So, 4 to 3. Then the next will be given by G of 3 pi. You go with the G of 3 pi. So, what is the G of 3 pi? Go to the G of 3 pi. The G of 3 pi is nothing but only one equation, that is nothing but the cost of 3 1, that is a base case. Nothing but from 3 to 1 you must be reach. So, this is the path. That path only gives us the minimum cost. What is the traveling salesperson problem cost? 35. So, we are going to check it once, cross check. What is the value of 1 to 2? Now, check what is the value of 1 to 2? 10. One to 2 is the 10 plus what is the value of 2 to 4? 10 plus what is the value of 4 to 3? 9 plus what is the value of 3 to 1? 6. What is the total value? 10 plus 10 20, 20 plus 9 29 plus 6 35. Yes, our answer is right. Now, think. So, this is about the traveling salesperson problem. Now, if you are following this method, this is our algorithm just now we discussed. So, what is the time complexity of this algorithm? Nothing but observe the sites. What is the number of sites it gives us? The time complexity is, if you are clearly observe, which is like 2 power n, and if you are going to be clearly observe, every time it is going to be verify from all the possible sets for each and every vertex. That is nothing but each and every element is going to be compared with other set elements. So, that is nothing but n minus 1 into n minus 2 max, nothing but n square. So, this is the worst case time, order of n square into 2 power n, or otherwise simply you are going to be say order of 2 power n. So, this is about the traveling salesperson problem. Thank you.